For a 400 amp single-phase main, you will need specific wire and conduit. The recommended wire size is 500 kcmil THHN/THWN-2 copper wire. The suggested conduit size is 3-inch rigid galvanized steel conduit, often referred to as RGS. Regarding the conduit entry location, you can enter the main from either the side or the back. However, it is crucial that the conduit is properly supported and protected from potential damage. Several installation requirements must be followed. Firstly, adhere to all applicable electrical codes and standards. Secondly, the conduit must be grounded using a grounding bushing. Thirdly, ensure the wire is properly sized, connected, and protected by circuit breakers. Fourthly, the main should be installed in a suitable location, such as an electrical panel or meter socket. Fifthly, the conduit should be sealed at the entry point to prevent moisture penetration. Lastly, the complete installation should be inspected and approved by a qualified electrician. There are a few additional notes to consider. Firstly, the size of the weatherhead will depend on the wire size and the number of conductors entering the main. Secondly, the length of the conduit should be minimized to reduce voltage drop. Thirdly, always use appropriate fittings and connectors to ensure a secure and weatherproof installation. Let's elaborate on the wire selection. THHN and THWN-2 are both insulation types that are commonly used for electrical wiring. THHN stands for thermoplastic high heat resistant nylon coated, while THWN-2 stands for thermoplastic heat and water resistant nylon coated. The 2 in THWN-2 indicates that it is rated for wet locations at a higher temperature than THWN. 500 kcmil refers to the cross-sectional area of the conductor. Kcmil stands for 1000 circular mils, and it's a unit of measurement used to express the area of a wire. A larger kcmil value indicates a thicker wire, which can carry more current. Copper is a popular choice for electrical wiring due to its excellent conductivity, ductility, and resistance to corrosion. When selecting wire, ensure that it is rated for the appropriate voltage and temperature for the application. For conduit selection, rigid galvanized steel, or RGS, is a type of conduit that is commonly used for electrical installations. It is made of steel and coated with zinc to protect it from corrosion. RGS is a strong and durable conduit that can withstand physical damage and environmental factors. The 3-inch size refers to the inside diameter of the conduit. The appropriate conduit size depends on the number and size of the wires being run through it. The National Electrical Code, or NEC, specifies the maximum number of wires that can be installed in a conduit of a given size. When selecting conduit, ensure that it is approved for the intended use and that it meets all applicable codes and standards. Now, regarding conduit entry, the location of the conduit entry point into the main electrical panel or meter socket is often determined by the specific installation requirements and the layout of the building. Entering from the side or the back is generally acceptable as long as the conduit is properly supported and protected from damage. Proper support can be achieved by using conduit clamps or straps to secure the conduit to the building structure. Protection from damage can be achieved by routing the conduit in a location where it is not likely to be hit or damaged by vehicles or other objects. It's essential to consider the bending radius of the conduit when making turns to avoid damaging the wires inside. Grounding is a critical safety measure in electrical installations. Grounding provides a path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse and prevent electrical shock. A grounding bushing is a type of fitting that is used to connect the conduit to the grounding system. The grounding bushing must be properly installed and connected to a grounding electrode, such as a ground rod or a water pipe. Now, concerning circuit breakers, they are essential components of an electrical system that protect against overcurrents and short circuits. Circuit breakers are designed to trip and interrupt the flow of electricity when the current exceeds a safe level. The circuit breakers that are used to protect the 400 amp single-phase main must be properly sized for the load. This means that the circuit breakers must be able to handle the maximum current that the main is expected to carry. It is also important to select circuit breakers that are appropriate for the type of equipment being protected. Some equipment, such as motors, may require special types of circuit breakers. As a review, the location of the main electrical panel or meter socket should be carefully considered. The main should be installed in a location that is easily accessible for maintenance and repairs. It should also be located in a dry and well-ventilated area to prevent corrosion and overheating. The main should be mounted securely to the wall or other supporting structure. Sealing the conduit at the entry point is an important step in preventing moisture penetration. Moisture can damage the wires and other electrical components, which can lead to electrical hazards. The conduit can be sealed by using a sealant or caulk that is specifically designed for electrical applications. The sealant should be applied to all openings around the conduit entry point. Finally, it is important to have the installation inspected and approved by a qualified electrician. A qualified electrician has the knowledge and experience to ensure that the installation meets all applicable codes and standards. The electrician will also be able to identify any potential safety hazards and make recommendations for corrective action. Failing to have the installation inspected and approved can result in serious consequences, including electrical fires and injuries. Let's look at those additional notes once more. The size of the weatherhead depends on the wire size and the number of conductors entering the main. The weatherhead is a protective cap that is installed at the top of the service mast to prevent rain and other debris from entering the conduit. The size of the weatherhead must be large enough to accommodate the wires and connectors that are being used. The length of the conduit should be minimized to reduce voltage drop. Voltage drop is the decrease in voltage that occurs as electricity flows through a wire. Excessive voltage drop can cause equipment to malfunction or fail. The amount of voltage drop that is acceptable depends on the type of equipment being powered. The NEC specifies the maximum allowable voltage drop for various types of equipment. Appropriate fittings and connectors are essential for ensuring a secure and weatherproof installation. Fittings and connectors are used to join sections of conduit and to connect wires to equipment. The fittings and connectors must be compatible with the type of conduit and wire being used. They must also be properly installed and tightened to prevent leaks and loose connections. In summary, installing a 400 amp single-phase main requires careful planning and execution. It is important to select the appropriate wire and conduit sizes, follow all applicable codes and standards, and have the installation inspected and approved by a qualified electrician. By following these steps, you can ensure that the installation is safe, reliable, and meets all applicable requirements. Remember to always prioritize safety when working with electricity. If you are not comfortable performing the installation yourself, it is best to hire a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents. Also consider local codes that could require different components. For example, depending on local requirements, aluminum wire may be acceptable instead of copper. Always check local electrical codes before starting any electrical project. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Consult with a qualified electrician or other professional before starting any electrical project. Incorrect wiring can lead to electrical shock or fire. Be sure to get proper professional consultations before doing any work. Always ensure that power is disconnected from the circuit you are working on before starting any work. Double check with a non-contact voltage tester or multimeter. If you are unsure how to safely disconnect power, consult a qualified electrician. Always wear appropriate personal protective equipment such as safety glasses and gloves when working with electricity. Do not work alone, have someone nearby in case of an emergency. Keep your work area clean and free of clutter. This will help to prevent accidents and make it easier to work. Use the right tools for the job. Using the wrong tools can damage equipment and create safety hazards. If you are not sure how to use a tool, ask for help. Do not work when you are tired or distracted. It is important to be alert and focused when working with electricity. Take breaks as needed to avoid fatigue. Do not work in wet or damp conditions. Water is a conductor of electricity, so working in wet or damp conditions can increase the risk of electrical shock. If you must work in wet or damp conditions, take extra precautions, such as wearing rubber boots and gloves. If you experience an electrical shock, seek medical attention immediately. Even a mild electrical shock can cause serious health problems. Be aware of your surroundings. Be aware of potential hazards, such as overhead power lines, buried cables, and other electrical equipment. Keep a safe distance from these hazards. If you see something that looks dangerous, report it to the appropriate authorities. By following these safety tips, you can reduce the risk of electrical accidents and injuries. Electricity is a powerful force, but it can be used safely if you take the necessary precautions.